Hi everyone. Today we're going to be doing lesson 3.3, which is finding the slope of a linear relation. Okay, so throughout today's lesson, you will learn what slope actually means. Okay, another way that we talk about slope is sometimes we call it the rate of change of a linear relation. Okay, so if you hear the word slope or rate of change, they're referring to the same thing, okay? So, rate of change is defined as a ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable, okay? And on a linear graph, this is called the slope of the line, okay? So rate of change is the ratio, and when we're talking about graphs in the graph of a linear relation, we call rate of change the slope, okay? So again, slope is written as a ratio, right? Remember, a ratio is just a comparison of two quantities. So it's a ratio of the vertical change, which we will call the rise, the vertical change, to the horizontal change, which sometimes we call the run, okay, between any 2 points on a line, right? So between any 2 points, right, let's say we have a point here and we have a point here, the slope is going to be written as a ratio of how much we went up, right, the vertical change, and how much we moved over, the horizontal change. Okay, so it's a ratio of how we move from one point to the next on the same line. Okay, and regardless of which 2 points you use, as long as it's the same line, the slope is going to remain constant. Oops. The slope is going to remain constant for any 2 points on the same line. So slope is written, instead of writing it as a ratio of A to B, like we sometimes see, instead we write slope as a fraction, right? Where we have A over B, right? So slope is written as a fraction, right? Where we have the vertical change to the horizontal change, and it's written in simplest form. What do I mean by simplest form? Well, that means you need to reduce your fraction, right? Reduce the fraction to the lowest possible terms. Okay? Now, in math, we sometimes use variables to represent different things. So when we talk about the equation of a line, the variable we use to denote slope is going to be m. Okay? M for slope. Okay? Now, there are different types of slope that we have, and they depend on obviously the equation of the line that we're given. But there's 4 main types, okay? So there is a positive slope, which would be increasing, right? Actually, you know what? I got to use a straight line, right? So this is a positive slope. Why? Because it's increasing as we go from left to right, right? Positive. It's increasing as we go left to right, okay? The next type is, well, a negative slope. A negative slope is when we're decreasing as we go left to right. We're decreasing as we go left to right. So the line is going down. Okay, and that's a negative slope. Okay, now in some cases, we actually get a slope that is horizontal, right? It's a flat slope, okay? Meaning it's not increasing at all. So in that situation, we would say the slope of the line is 0. Okay, and we will do examples where I explain, why it's 0. Finally, the last type of slope is when you have a vertical line. Okay, a vertical line, right, where we're not doing any horizontal changing. We're just going up or down. And when we have something like a vertical slope, we call the slope undefined. Okay, meaning slope does not exist. Okay, so when we have a vertical line, there is no slope. It's undefined. Okay, and we will do examples about using vertical lines in this lesson. Okay, so remembering that slope is a ratio of the vertical rise. So let's just go over that. Slope is a ratio of the vertical rise change to the horizontal change, right? So we can write M, remember M represents slope. We're going to write slope as the rise over the run, okay? And we're going to do that to calculate the slope for each one of these linear relations, okay? And we're going to also remember that slope needs to be reduced into its simplest form, okay? So for example, 4 over 2 would have to be reduced to 2 over 1, or just 2. Okay, let's try it. So we see here that we are given 2 points on the line, right? I could have chosen any 2 points. It doesn't really matter, but these 2 points are nice, clean coordinates, right? They meet right at a corner, at a coordinate. So what we're going to do, we're going to figure out, well, what is the rise and what is the run? How much did we have to climb vertically? So what I'm going to do is I'm going to draw a line up. Oh, that was supposed to be a line. Let's see here. Let's go with a different color. Maybe that. Okay, so we look at the vertical rise, okay, and then we look at the horizontal change, which we call the run. All right, and now what we have to do is we just have to figure out, well, what is the rise and what is the run? So how much did I climb? Well, I started at -2. Let me zoom in a little bit more. I started at -2 and I climbed all the way up to +2. So how much should I rise? My rise, oops. One sec. Sorry, guys. Okay. Let's get the pen. My rise is equal to 4, right? I climbed 4. I went up 4. Okay. And my run, well, how many spots did I move over on the x-axis, right? Well, this point is at -2x, right? It starts at -2 and it goes to +3, right? So my vertical run, -2 to +3, well, hopefully you guys can see that that's 5. Okay? Now, M, we have to make sure that we write it properly, right? M, it's not run over rise, it's rise over run. So vertical change over horizontal change. So in this case, we would have a slope of 4 over 5. okay? And we can't simplify that, right? That's a reduced fraction. So the slope of this line is 4/5. Let's go with question 2. Same thing, okay? So again, we have 2 points that are already identified for us. So let's talk about the rise. So again, I'm going to draw a vertical line up, okay? And then the run, okay? So how much should I rise? How much should I climb? Well, I started at -3, and I went all the way up to +3. So my rise is 6, okay? Now my run, I started at 0, and then I moved to 3. So my run is equal to 3, okay? So M, rise over run, so 6/3, but that's not simplified. So we have to simplify it to M is equal to 2. Okay, and that would be our final answer. Just like 4/5 was our final answer here. Okay? I mean, you can leave it if you want. You can leave it as 2/1, but we don't need to do that. We can just leave it as 2. Okay? Because if you prefer to write M as a ratio, 2/1 is appropriate. Okay. So what you guys may have noticed, or maybe not, is that in the 2 first examples we did, if you look at my axes, my X and Y axes, you'll notice that I have numbers on my number line, right? And each new line counts for 1 unit. So that's typically how we set up a graph, okay? But remember, our coordinate plane is just the intersection of a horizontal number line with a vertical number line. And with number lines, right? With number lines, we do not always have to count by 1. Like for example, I could go 0, I could count by 5 if I wanted on a number line. I could count by, really anything on a number line. So we have to make sure that we're able to do that. And this is called the scale of the axes, okay? So I'll write that. This is the scale of the axes. Okay? So let's move on to question 3. Okay. So what is different about this graph? Well, look at the scale, okay? Look at the scale. We are no longer counting by 1s. We're counting by 2s in both directions, okay? So we just need to be aware of that, and we need to remember that when we're finding our slope, okay? So let's calculate slope. So again, we have 2 points. 2 points, right? One here. Oh, one here and one here. So first we do our vertical change. Well, in this case, we're not climbing like we were for the other 2. In this one, we're going down, okay? And then for our horizontal change, we are still going this way, okay? So, oops. Right? So let's talk about this, right? Our rise, well, we didn't technically rise. We went down, okay? Well, to keep track of the direction, we're going to write it as a negative rise. So it's 2 squares, right? But we have to remember that we're not just counting squares. We are looking at the axes. So the rise, it went from 4 down to 0, right? You can see that. It started at 4, went down to 0. So my rise is going to be equal to -4. Not -2, -4. Okay? And now my run, well, my run is still positive, okay? Because I'm still going from left to right. So my run, I start at -6 and I end at +6. So that's a run of 12. 12, right? From -6 to +6. Okay? So let's write out our slope. So m is equal to rise over run. So that would be -4 over 12. But that can be reduced, right? That can be reduced to -1 over 3. Okay? So look, we have a negative slope. And that's exactly what we expect, right? Because if we remember of the different types of slope, a negative slope has to be pointing down. And that's what we have here. Our line is pointing down. Okay? All right. So let's move on to this question. Okay? So let's look at our scales here. Now we're counting by 5s, okay, instead of 1s or 2s. That's okay. And we're counting by 5s in both the x and the y direction. So let's go ahead with our rise and run, okay? So our rise is going to be negative, right? We're climbing down. So our rise is actually, don't mind my not straight line, but my rise is to there. And my run is to there, okay? So again, my rise, I'm going down, so I know it's going to be a negative rise. Okay, something negative. So let's look. We start at 20 and we end at -15. Okay? That means it's a total of 35. Okay? 35. We went down by 35. If you do 20 minus 35, you're going to get -15. Okay? And our run, well, look, we go from -5 to +15. So that's a run of 20. Okay? Very good. So let's write our ratio. So rise goes on top, and then run goes on the bottom. Now these can be simplified, can't they? They can both be divided by 5, which gives me -7 over 4. Okay? -7 over 4. Now, some of you may notice that, hey, miss, why didn't you just count the squares, right? So if I counted the squares, I would have 1, 2, 3, 4, 5, 6, 7. I would have -7. And if I just counted the squares, I would have 1, 2, 3, 4 over 4, which gives us the same answer here. Okay? So, yes, that would have worked by counting the squares, but it only works because both of our scales, our y-axes and our x-axes, both count by 5. If they didn't both count by 5, then we wouldn't be able to do that trick. Okay? So that's why I want you guys to pay attention to the numbers on a scale instead of just counting boxes. So hopefully that makes sense, okay? We'll do some examples where you guys will see where the X scale and the Y scale are not identical. All right, so let's go on. Let's do question 4. Okay, so this is good. So let's look at this. We have a horizontal scale. We're counting by 2s, okay? In our vertical scale, we're only counting by ones, but that's okay. All right, so this is a vertical line. Now, we already know that M is going to be undefined, right? That's what I told you guys. Undefined when we have a vertical line. But let's explain why undefined. So again, with M, we have rise over run. Whoops. So let's pick 2 points, okay? Any 2 points, all right? So my rise is going to be down, okay? So my rise is going to be, I go down by 6. So rise equals -6. But what is my run? My run is 0. I didn't move at all. So when we create our rise over run, we end up with some number divided by 0. Well, we're not allowed to divide anything by 0 in math. It's not allowed, okay? So that's why we call it undefined, okay? And that is for vertical lines. Okay, 6. So here we can see we are going to have a positive slope. Now let's look at our scales, okay? So on my y-axis, what am I counting by? I'm counting by 4s, okay? And on my x-axis, I'm only counting by 2s, okay? So my y and my x-axis are not the same. So I need to be careful, okay? So let's start by doing our rise. So again, we start at the first point and we go up, right? And then we're going to go across. We're going to do our run. Okay, so rise, what does rise equal? It's positive because we're going up, but we went from -16 all the way to 0. So we rose by 16. We went up 16 units. Our run, well, we started at -8 and we went all the way to +8. Well, that is 16 as well. Okay, so my slope is going to be rise over run, 16 over 16. Or simplified, M is equal to 1. Okay? All right, let's do some more. So again, we have 2 points, and we know that this should give us a negative answer, right? Because the slope is going down. Okay? So let's do rise and run again. So rise goes down, run goes across. Oops. Run goes across. Yep. Just like that. Okay, so rise. My rise. It's going down, so it's going to be negative. Okay? So I started at 50 and I went down all the way to 100. Okay? That's a change of -150. Right? It went down by 150. The run, let's see. Well, I started at -1 and I went all the way to +3. So my run is 4. All right. So see how the scale it really plays with you because the y-axis is so different than the x-axis. But we will come across graphs that look like this, so we have to get comfortable with it. Okay, so let's write M. We get -150 over 4. Okay. Now that can be reduced. It can be reduced because both of those are even numbers. They can be both divided by 2. So that gives me 75 over 2. And that's my rate of change. Okay, so sometimes rate of change comes out to some fraction that doesn't look very pretty, but that doesn't matter, okay? Regardless of how weird your answer looks, it could still be correct as long as we follow the rise over run. Okay, moving on to question 8. Here we are counting by 10 and 10. So we're using the same scale for our x and y axes. And remember, when we have the same scale for x and y, we are allowed to count squares, okay? So let's see. So our rise, we go up from this point all the way up to here. And our run, we go all the way across. Okay, so we're allowed to count squares because it uses the same axes. Okay, so I mean, technically, my rise is technically 40, right? Because I went up from -20 to +20. But let's see if just counting squares will work. So let's see if instead I put rise equals 4. Okay? Now, with my run goes from -50 all the way to +50. So technically my run is 100. Okay? But let's see if counting squares will work. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 10 squares. Okay? So let's just make sure that we get the same answer. So remember, M, rise over run, so 40 over 100. Does that give us the same answer as 4 over 10? Yes, it does, okay? They both reduce because this one can be simplified to 4 over 10, right? And then further simplified to 2 over 5. And this one can be simplified to 2 over 5 as well. So both of our methods gave us the correct answer. So if you're paying attention, you are allowed to count squares, but only when the x and y scale are identical. Okay, a couple more. Number 9. So again, we identify our scale. So we're counting by 2's on our y and 1 on our x's. So we can't just count squares, right? We have to look at the numbers. All right, so it's negative, it's going down, so our run is negative, okay? And we go from 6 to -2. So that gives us a run of -8, okay? Sorry, geez, not run. A rise, right? Whoops. A rise of -8, okay? And then our run, well, we're just counting by ones here, right? So that was a 1, it goes to 2. So our run is 1. Okay? So m equals rise over run. So -8 over 1. Okay? You can leave it like that. Looks a little funny. Usually we would just write it as -8. Okay? We would just kind of leave out the 1. Here we go. Okay, we have a horizontal line this time. And if we quickly go back to, the previous page and we look at the types of slope, right? We know that a horizontal line should give us a 0 slope. Okay? So let's check it out. Let's go see. So we think, or we're told, that m is equal to 0. And let's see why that's true. Okay? So again, let's just pick 2 points at random. Okay. Now my rise, What is my rise here? My rise is 0. I'm not going up. I'm not going down. Now my run is moving, right? I'm going from -3 to +1. So my run is equal to 4. Okay, so let's see what happens. M is equal to 0 over 4. Okay? This time, 0 is on the top of the fraction. Okay? We're allowed to take 0 and divide it by a number. Okay? This will give us 0. Regardless of what that number is, we're always going to get 0. 0 divided by anything gives us 0. Okay? So the difference between the vertical and the horizontal line, right, is because of the ratio, right? So with our with our vertical line up here, we were dividing by 0. And dividing by 0 is not allowed, okay? With our horizontal, right, we're not dividing by 0. It's 0 being divided by something else, okay? So there's a difference. And that's why we say that for a vertical line, the slope is undefined, while with a horizontal line, the slope is 0. Okay. Couple more. So rise, going down. Oops. We are going down on this one, right? Negative slope. So we go down. And how much should we go down? It's negative, right? So we started at 8 and we went to -2. That's a rise of -10. Okay. My run, well, you have to look at your scale, okay? My run, I went from -15 to 0. So my run is equal to 15. All right, so M is rise over run, -10 over 15 can be reduced to -2 over 3. -2 over 3. Okay, number 12. Okay. So sometimes scales will even see decimals in scales. So if you look at our x-axis here, we're counting by 0.5. Okay, sometimes that happens. All right, and then our y-axis, we're counting by 3s. So let's go ahead. This is positive slope, right? We can see it's increasing. So our rise is going up, 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 up. And our run goes over. Okay, so rise, it's positive. And we start at -12 and we go all the way up to +6. That is a change of 18. Okay, it's a change of 18. My run, well, I went from -0.5 to 1.5. Okay, -0.5 to 1.5. So that gives me a total run of 2. Okay, total run of 2. Okay, so slope, rise over run, 18 over 2, simplifies to 9 over 1, or simply 9. All right, let's go for the last one. Okay, so 13. Here, I haven't labeled every single tick mark, right? Sometimes that's the case. Sometimes, every second line will be skipped, and that's okay. We just have to figure it out, right? So if we see on my x-axis, as I go from 0 to 4, right, I cross two lines. So if this is 4, if 4 is right here, then this here must be 2. So I must be counting by 2s. Every line, every unit is 2. So this is 6, right? This is -2, this is -6. Same thing on our y-axis, right? That's -2, that's -6, +2, +6, +10, right? So we sometimes the numbers don't have to be at every single line, if that makes sense. Okay, so rise. We're going up. How much are we going up? Well, we started at, what is this again? Well, it's right between -4 and -8, so it must be -6. And we go all the way up to 8. So that gives us a rise of +14. Our run goes from -8, that's an 8, you can't see, that's -8, all the way to +6. Remember, that must be +6. So the run is also equal to 14. Okay, so rise over run, we get 14 over 14, which is just a slope of 1. So the slope is +1. And, right, because the same scale was used on the x and y axis, we could have technically just counted squares here, right? For example, if I count the rise and I just count squares, 1 square, 2, 3, 4, 5, 6, 7, over 1, 2, 3, 4, 5, 6, 7. So 7 over 7 would also give us 1, okay? All right, last but not least, we have question 14. So let's look at the scale. Okay, so we don't have the same scale. On our y-axis, every second line is 30, okay? So what does that mean about right here? What is that value? Well, what's half of 30? It's 15, right? So technically that's 15. What's between 30 and 60? That's 45, okay? And then it would be the same thing, right? This would be -15. That would be -45. And then on our x-axis, right, what are we counting by? So again, every second line, we're counting by 20. So that means between 20, that must be 10. This must be 30, right? We figure out what we're counting by. Okay? So let's do it. This is a negative slope. It's going down. So our rise is negative. Rise equals, so we go from -15, sorry, all the way to -30. So that's a rise of -15. My run, I go from -30 to +20. So my run is equal to 50. Okay. So let's go. We get -15. Remember, rise over run, -15 over 50. We can simplify that. M is equal to, so divide both by 5. We're going to get -3 over 10. -3 over 10. Okay, so there you go. That's the lesson for this week. There is an assignment that goes with it, some practice problems. I'm going to get you guys to complete that and submit it for me to make sure that you understand all these concepts. Okay? Take care, guys.